Let me just start out by saying what I present on my channel is an alternative theory, and it's not something you're going to find in mainstream physics. So you're going to hear things here on this channel that you would never hear anywhere else in physics, and today's lecture is no exception. And if you want more information, you can always pick up a copy of my book, Einstein and Aliens, which is available on Amazon.com. Everything in these lectures is included in the appendices of the book. The second half and the first half is a science fiction adventure that covers all the subject matter as well, but from a storytelling point of view. Hello, I'm Hugh Manfield, and welcome back to the Fluid Space Theory lectures. Today we're going to be talking about black holes. And everyone knows that a black hole is an object with such strong gravity that it crushes everything down into a singularity below an event horizon, and not even light can escape. Now, this is the construction of a black hole that everyone knows and is embedded in the physics mindset of the day. In fact, it's embedded so far that it may be hard to change, but it needs to change because it may be cool, but it's wrong. Everybody contributes this style of a black hole, this conception of a black hole, to Einstein, but I'm not really sure he was the one who came up with it, because this construction of a black hole is actually something you would get if you used Newton's laws. So what does fluid space theory say about black holes? Well, it tells a little different story. If you remember back to my earlier videos, you think about space-time flowing down a funnel. It becomes tangent at the event horizon, at the Schwarzschild radius. And what this means is that if you're moving inward toward the center of the field, as time becomes dilated and space becomes length contracted, you begin to turn a dimensional corner. And by the time you reach the event horizon, everything's been length contracted down to zero, and you've gone off perpendicular to our universe, perpendicular to the inward direction. So what fluid space theory shows is that space-time doesn't extend beyond the event horizon. There's a space-time discontinuity. And this is quite a bit different concept from a singularity, but it's almost even stranger. Because what you have is an infinite corridor of space-time leading inward that actually doesn't go anywhere. It never gets beyond the Schwarzschild radius, and you have a spherical domain that is not part of our universe. To explain a little better what I'm talking about, we take Newton's law of gravitation, gravitational constant times the mass over the radius squared. It's the inverse distance squared equation. And when we plot that out, we get this green line, and it goes up off the chart to infinity when it reaches zero. And then it diminishes with distance into something very small at great distances. So if you take Newton's law and you apply the Lorentz transformations for length contraction and time dilation, you get a different curve. And it's almost the same curve out here at large radiuses, but at smaller radiuses, it begins to diverge, and it actually reaches a peak where the acceleration then drops off rapidly to zero at the Schwarzschild radius, which would be the event horizon. So you can see by these mathematical functions, Newton's law is the one that goes all the way to zero, to a singularity, where if you account for relativity, it tells us that the acceleration goes to zero at the event horizon. And that means that gravity vanishes at the event horizon. So that seems pretty strange, because everyone's used to thinking of gravity getting stronger and stronger and stronger and crushing everything down to a singularity. But fluid space theory says something else. So to make it a little clearer, if we remember fluid flowing down the funnel of fluid space theory, and as it becomes length contracted and time dilated, it starts to change the shape of the funnel into a hyperbolic funnel. And the greater it becomes length contracted and time dilated, the more that funnel begins to turn into a straight pipe. So what happens when fluid flows down a straight pipe? Well, it doesn't accelerate. It's a constant flow, which also then supports the concept that gravity vanishes at the event horizon. So of the two different conceptions of a black hole, the one with the singularity is really built on Newton's laws and using classical theory. And if you really embrace relativity, you have to look and accept a different concept of a black hole that becomes tangent at the event horizon and surrounds a discontinuity in space-time. And this changes our basic concept of matter. Now, Einstein held to the classical belief that matter travels through a void of space. And these are two separate things. He even set up his field equation with the matter on one side, space on the other. You may have heard matter tells space how to curve and space tells matter how to move. Well, that's an example of his philosophy of the separation of space-time and matter. So he didn't object to this construction of a black hole because it had a singularity and it had a place for matter to go. Even though Einstein came up with the energy-matter equivalence equation, he still didn't abandon his classical roots, and he believed that you needed some place for the matter to go. And he would never consider what I'm about to show you. So I'm going to use some engineering terms here. And we have a diagram with our unit cube of space-time, and we set it into motion so that the rest length is x, and the observed length in motion is x prime, according to special relativity. And we define what I call a spatial strain, and that is defined a similar way that we do for strains in engineering stress analysis. The uncontracted length minus the contracted length divided by the original uncontracted length defines a strain, and this is going to be a number between 0 and 1. So if x is the uncontracted length, we apply the Lorentz transformation to x. That's the contracted length divided by x, and it gives us this value here. So to find out the energy that is involved in a space-time distortion or space-time strain, we use a standard linear stress-strain curve where the force or stress is plotted against the deflection or strain. We have a linear relationship, and the energy is the shaded area under the curve. We have the energy equals the volume times Young's modulus. So the force or stress is going to be Young's modulus times the strain, and we have the strain over here. So we get Young's modulus times the strain again, and then we divide it by 2 because we want half of this rectangle. And that's going to define the strain energy. So now if we make some substitutions for Young's modulus, I use 3c to the 4th over 4 pi r squared g, and you might recognize something similar to this from Einstein's field equation. I'm using something just a little bit different, but it's serving the same purpose. And we have the volume of the sphere as our volume, the Young's modulus, strain squared, and when we turn the crank, we get this equation, which is the energy as a function of velocity and radius. Well, if we want to do it as just a function of radius, then we have to make one more substitution. For v, we put in the escape velocity, which is the velocity that the fluid will be flowing down the funnel in fluid space theory, and we get an equation for the energy of a gravitational field as a function of radius. And that represents the energy that's accumulated between a strain of 0 and any strain in question. So the strain of 0 occurs out at infinity, and then as we bring it into a specific radius, we can get the total energy accumulated up to that point. So what if we plug in the minimum radius, which is the Schwarzschild radius, at the event horizon? When we plug that in, we get that the energy of a gravitational field is equal to mc squared. Now this is no coincidence. We've just arrived at Einstein's energy-matter equivalence through an entirely different approach. And we've confirmed what Einstein discovered in his approach. But what this tells us with fluid space theory is that matter doesn't curve space-time. Matter is curved space-time. The energy in a gravitational field is the same as the rest mass of the particle, which means by the time you get to the event horizon, gravity goes away and there's nothing left to go further down the black hole, because the field itself is the mass. And this changes our concept of matter entirely. The fluid space concept of matter is that we have voids or discontinuities in space-time, little spherical bubbles in our cosmos that are surrounded by very intense energy fields. And these energy fields stretch out and reach out to each other. So the substance of our cosmos lies not in the little spheres, but in the space between. So according to fluid space theory, the cosmos is an infinitely complex single thing. Now, one of my favorite animated characters is Autumn Blaze. And Autumn Blaze thinks that maybe there's just one thing and we're all it. Well, Autumn, you're right. There is only one thing and we are all it. And I've just shown it scientifically. Every single bit of matter in the universe is actually a space-time discontinuity surrounded by an energy field. And these energy fields reach out to each other on and on and on forever to form the one great everything that is the cosmos. And that's something to think about. So until next time, I'm Hugh Manfield.